Everyone, we are from Group 11 and today we are excited to take you on a deep dive into one of the most promising frontiers of the global green energy transition. This is hydrogen-based energy storage. As our world faces an urgent climate crisis, heavy industries, especially the maritime sector, are under intense pressure to find zero-emission alternatives to traditional fossil fuels. However, to understand the engineering behind our case study, we must define what hydrogen actually is. In this context, hydrogen is not a primary fuel source like coal or oil that we simply extract from Earth. Instead of decades, energy carry things of it's using the rechargeable environment and analogy under this energy bank.
To see these theories in action, we turn to a global pioneer, the MF Hydra. For decades, the maritime industry has relied on heavy fuel oil, contributing significantly to global CO2 emissions. However, the International Maritime Organization has now mandated strict greenhouse gases reduction for all vessels. The MF Hydra, developed by Norway, is the world's first ferry powered by liquid hydrogen. It began its historical commercial operation in 2021 and remains active and operational today. This vessel is a game changer because it reduces carbon emissions by a staggering 95% compared to traditional diesel engines. By moving from theoretical research, it's proven commercial reality. The MF Hydra serves as the first industrial blueprint for zero-emission marine vision.
Hydra operates on a circular and sustainable hydrogen energy cycle. Phase 1 is charging or production. We use electrolysis to split the water into hydrogen and oxygen, but there is the engineering reality. To produce just 1 kilogram of hydrogen, we require 9 liters of ultra pure water. If the electricity comes from renewable source, we produce hydrogen with zero carbon emission. Phase 2 is storing. Hydrogen is the winner in gravimetric energy density, packaging 120 mJ energy per kilogram, nearly 3 times of diesel. However, as a gas, it takes up too much space to pack enough mass for a ship. We use cryogenic storage, cooling and gas to an extreme 253 on board the ship, and hydrogen is fed into fuel cells. This is the exact reverse of electrolysis. It's combined and to generate electricity silently with pure water vapor of only exhaust.
The engineering architecture of the MF Hydra is built for safety and response. The liquid hydrogen is kept in specialized Type C tanks designed like giant thermos flask to minimize the boil-off problem. These are placed on the top deck of the strict safety regulation, require vertical venting in case of leaks. The ship's power is actually a hybrid system. We use the tortoise and the airy strategy. The fuel cell acts as the tortoise, providing steady, long endurance baseline power. Meanwhile, lithium-ion batteries act as the air, providing the instant burst of power needed for sudden spikes during maneuvering and docking. This synergy protects the fuel cell's lifespan and ensures the ship is highly efficient.
Finally, the infrastructure bottleneck. It remains where we need more hydrogen refilling stations at port to make this technology global. Here in Malaysia, we see an incredible opportunity through the hydrogen economy and Technology Road Track (HEDR). By leveraging our abundant solar potential and Sarawak's massive hydropower asset, we can transform Malaysia into a leading green hydrogen export hub. We are not just a student of energy storage, we are the future responder to these environmental challenges. We believe that integrating hydrogen technology is not just an engineering goal, but a responsibility to protect our maritime. What's made hydrogen truly an engineering choice? Beyond high energy density, hydrogen is incredibly safe in marine environment. It is 40 times lighter than air. In the lake, it shoots straight up into the atmosphere at 20 meters per second, rapidly dissipating rays. It is also 100% non-toxic to marine life. The primary hurdle is round-trip efficiency. We lost nearly 60% of the original energy during the conversion process from electricity to gas and back again. We also face material compatibility issues, specifically hydrogen embryomal, where tiny hydrogen molecules cause metal to crack over time.
In conclusion, the MF Hydra proves that liquid hydrogen is a safe and viable solution for clean energy storage. By mastering the hydrogen cycle, we move closer to a sustainable future. Thank you for your attention. Our reference include Yaya hydrogen based storage lecture notes, and then the MF Hydra case study, energy storage for power system, and last hydrogen production and storage mechanisms.